All right, today we'll talk about similar polygons, but before we do that, let's refresh our memory on what we did a couple chapters ago with congruent figures. Doesn't that mean that they're same size, same shape, right? Congruent to each other? Well, today is similar. So there are lots of things in this world that are similar to each other. In our own words, they'd be the same shape, but like different sizes, right? Similar figures are the same shape, but different sizes. So here's some examples, like a model car, right? So I don't know if you've ever seen model cars before, if you like to build them, this, that, or the other, but this right here is a model car of a 1966 Chevy Nova. It is the same shape of a 1966 Chevy Nova, but it is not the same size. Wouldn't that be ridiculous for it to be the same size as a 1966 Chevy Nova? So these guys are similar to each other. There's two rules, right, to be similar. That all the corresponding angles have to be congruent to each other, and all the corresponding sides have to be proportional. Here's an even better example of similar figures. This is a map of Kansas. Should a map of Kansas be the same shape as Kansas? Yes or no? Yes. Should it be the same size as Kansas? That would be ridiculous to have a map that is the same size of the state of Kansas. How would you fold it up? I mean, it would just cover the entire state if you unfolded that thing. That would be nonsense, right? So do you think that all the angles that go together should be congruent to each other? Like these crazy angles here in the old state where the river goes through right there, shouldn't those be pretty darn exact to what really is happening in real life? Now, everybody knows because it's a river, like they'll change a little bit here and there, you know, but shouldn't this angle be the same as what it really is between all the borders in real life and et cetera? If this is a 1966 Nova, shouldn't whatever curve that this fender makes be exactly the same as what the curvature on that fender is in real life, and et cetera, et cetera, et cetera? You get what I'm saying about the angles that correspond to each other. This fender better correspond to the real fender in real life, the angles on that. Make sense? But the corresponding sides, they cannot be the same as each other. They just be what we call proportional to each other. So like here in real life, let's say that's 400 miles in real life. You know, the border is just about 400 miles. There is absolutely no way that your map that's going to be 400 miles long, and et cetera, et cetera, et cetera. There's a scale factor involved. If you go to our model car, I know it's hard to read, but you see this 1 to 25 right there? There's a scale factor. What does that mean? That how many times bigger is the real car compared to this model car if it's a 1 to 25 scale factor? It's 25 times larger. So this tire right here is 25 times smaller than the real life tire, right? All the exact same measurements, but they just took a 25th of that, right? This windshield is 25 times smaller than that windshield, and et cetera. And obviously, you know on a map that there's some sort of scale factor. They say 1 inch equals so many miles or something like that. There's a scale factor involved. So to be similar, there are two rules. Let's write those two rules at the top of our practice sheet, as you'll see next. That corresponding angles will be congruent to each other. So write that at the top. Two rules to be similar. All right, this whole bottom statement down here, write that at the top of your practice worksheet. Two rules to be similar. That one corresponding angle should be congruent to each other, and two corresponding sides should be proportional to each other. Both things have to happen for it to be similar. Now, I've got to warn you, if you've got a weak stomach, the next slide is probably not for you. There's some very ugly things on the next page. So just be careful, but watch out. Ah! That's scary, right? They want to know if Mr. Dreyer's picture from the left to the right is similar to each other. Well, there's two rules. Number one, that the corresponding angles have to be congruent, correct? Now, it's not all these crazy angles in his face. It's the overall shape is a picture, right? Take a wild guess what you would estimate that angle to be right there. 90, 90, 90, 90. Is it 90, 90, 90, 90 in this picture also? Yes or no? So all the corresponding angles are congruent. Are the corresponding sides in proportion with each other? Well, this side right here is 8 inches, and doesn't it correspond with this side right here, which is 4 inches? What's the scale factor back and forth? 8 over 4, right? Which reduces to what? 8 over 4 doesn't reduce to a half. What's 2 to 1? Isn't that a 2 to 1 ratio? This is twice as big as that, correct? Is that the same proportion here? If I went 8 over 4 this time, don't I have to go 6 over 12 this time also, right, to keep it in the right proportion, just like vanilla over eggs? Better equal vanilla over eggs. Are you with me on that? Do you get 2 over 1 when you do 6 over 12? No, that is not proportional. And these days, you've probably did a little bit of photoshopping or have experience with that, as you know that if you wanted to take this picture right here, to keep it proportional, you should drag the cool corner thing, which changes the length and the width by the same amount. If you don't, if you only drag one thing, it stretches it, and then the gap between the teeth gets wider and wider and wider and wider. So, not proportional. What do you think about that one? That's way better looking than Mr. Dreyer right there. Is Ms. Maska similar? Well, obviously, rectangular will assume 4 right angles, 4 right angles. Are we okay with that? Scale factor, 8 inches to 4 inches. What's the scale factor? Big over little. What do you got? 2 to 1. Is this a 2 to 1 ratio also? Those pictures are similar to each other because of those two rules. The corresponding angles were congruent, and the corresponding sides were in the same proportion each time. Sound all right? So, here we go with similar polygons. Okay, you got those two rules at the top. Here's the interesting thing. You've seen this symbol before, right? What's that symbol mean? That means congruent. Now look at this symbol. Isn't that just the squiggly part of it? This symbol means similar to each other. That thing means that they are similar. So they're telling us right here that ABCDE is similar to PQRST. That's called a similarity statement right there. This is a statement that states these two things are similar. Ladies, gentlemen, I've been doing this for a long, long time. There is one trick to these similar polygons / similar triangles that makes it the easiest problem in the world to deal with. Can you recognize the two guys right here? There's two different polygons. If they're similar, they're probably not going to be the same size, but they're going to be the same shape. Can you tell me which one's big and which one's little? Where's the big one, on the left or on the right? Put a giant B in that one. B stands for big. This would be the little polygon then. Put an L in there. It seems so elementary to do that B and L for big and little, but it saves lives. That little bit of a step right there makes everything work out just perfect. Before they ask us to do all kinds of crazy things, they just want us to answer these questions. This worksheet was typed years ago before all the cool equation editors. This is supposed to say angle A is congruent to. Well, aren't the two rules, one, that corresponding angles are congruent to each other? Come on, man. My pen's not wanting to work. Sorry. And what's rule 2 again? I forgot. What's rule 2? Corresponding sides are proportional. That proportional thing is just that scale factor of 2 to 1, 2 to 1. Just like back here, didn't we get the scale factor of 2 to 1 right here? And this was the same scale factor of 2 to 1. That's the same scale factor every time. That means they're proportional to each other. Here, it was a 2 to 1 and a 1 to 2. That's not the same scale factor both times, so they're not proportional to each other. So back here, they're saying, well, what's angle A congruent to? Well, I already know that these guys are similar because they told me so up there in that statement. And they're in corresponding order, so A comes first. What does it correspond with? P. So angle P. Angle A and angle P are the exact same thing. That means that, just pretending, if this was 90 degrees, what does that got to be? 90 degrees, because they're similar, and all the corresponding angles in similar figures are congruent to each other. Sound all right? What is angle B congruent to? Angle Q. And you fill out what angle C is congruent to. What am I trying to do? What's angle C congruent to? Not R. Angle R. With me on that? Make sure you put the cool angle symbol. Then these guys right here, This is saying some sort of proportion. Does anybody know how to say this out loud? What does that say? That's the distance from A to E, and this means is proportional to, it's a fraction bar, right, is proportional to the distance from P to T. Well, you can tell up here, here's A to E, right, if you look at your statement, and P to T, don't those correspond to each other and everything like that? The thing is, I can see it in your faces. It's like, dude, I can see what corresponds to what in these pictures. They're sitting right next to each other. They look like the exact same thing. Oh, hold your horses, my friend, till next class period when this is rotated around, flipped over, and it's all maybe overlapping each other. Things get a little more complicated to see what corresponds with what. You don't want to look at the pictures. You want to read the similarity statement to help you answer those questions. So the similarity statement is where you're focusing all your attention on. They're saying distance from A to E is proportional to the distance from P to T. What would the distance from A to B be proportional to? Well, let's read this statement. Here's distance from A to B right here. What would it be proportional to? Distance from P to Q. Right? They're asking you right here to make up two more proportions that would have to work. Now, wait a minute. Let's try one more. What if I put, R to S right here? That just doesn't work. Because, do you see how, isn't this A to E from this guy right here, which is the little polygon, and this is the big polygon right here? Didn't they go little over big? That should equal little over big. Where's this one coming from? The big polygon. You can't do that. You can't switch the proportion around. That's like going vanilla over eggs equals eggs over vanilla. It just doesn't work that way, right? If they did little over big, you have to do little over big equals little over big, right? So give me a proportion here that makes sense. Give it a shot. What do you think, Dusty? Distance from C to D? Cool. Everybody got that? Now you answer the bottom part. What would it be proportional to? Distance from C to D would be proportional to what, my friends? Distance from R to S. Make up one more for yourself. I'll just make one up. How about distance from B to C? That was supposed to be B, sorry. B to C. What would that be proportional to? Q to R. Anything could have worked as long as they correspond to each other in your statement. You're good. Sound okay? But that's really the basics behind it. What we're going to do today is find the missing side lengths and etc. So first thing is, I know they're similar. How did I know they were similar in the first place? Can you help me? They told me so right here. Then I bigged and littled it. Cool? And here's what we do. We're going to do the same thing as a class every time. Every scale factor that you find for me will be big over little. Everyone got that? We always do big over little. So here's the thing. I need to find the scale factor between these two polygons. Here's what you need. You need to find two sides where you know both their lengths already, but they correspond to each other. So find two sides that correspond to each other and you know both their lengths. Study that with Pal real quick. Find two sides of this polygon that correspond to each other and you know both their lengths. So check this out. Here's a 12, right? What corresponds to this 12 in the other polygon? This. Do I know both their lengths? Yes or no? Nope, so that doesn't work for me. Here's an 18. What corresponds to that in the other polygon? Do I know both their lengths? Nope. But obviously, boom and boom. Don't those guys correspond to each other, and you know both their lengths, correct? So how will I write my scale factor? Let's do this. Scale factor. I think it might say that for you below. Scale factor. Should I do 20 over 32 or 32 over 20? We're going to do 32 over 20. Why 32 over 20? Big over little. Big over little. I know that says larger over smaller. Let's just call it big over little. Does that sound all right? Big over little. So, can that reduce, though, my friends? 32 over 20. Can that reduce? What do you want to reduce it by? 2? All right. So, 2 goes into 32 how many times? How many times does 2 go into 32? Thank you. And then 2 goes into 20. That's reduced. Did I reduce it all the way? Can we reduce it by 2 again? So that would turn into what over what? 8/5. If it reduced by 2 and reduced by 2 again, what number really went into both of them? 4 did. Our scale factor is 8/5. Cool? To find missing lengths in similar polygons, we must find the scale factor first. Sound awesome? Now let's use the scale factor to solve for x. So here's x, right here. Do we know what corresponds to x in the other polygon? The 12 does, correct? So here's what you do. You set up a proportion. We know that these are proportional because they're similar, right? Aren't the corresponding sides proportional? Rock and roll? So start with your scale factor. What's our scale factor? 8/5, right? 8 over 5. Now, I want to set that equal to, if I want to solve for x, should I do x over 12 or 12 over x? Now, how come you said 12 over x? Well, how do you know that 12 is bigger than x? Because I don't even know what x is. How do you know that 12 is bigger than x? Because it's in the big polygon, and that's where this and this are helpful. Doesn't 12 have to be bigger than 8 because it's in the big polygon? So 12 over x. With me? Now, how do you solve that proportion? Cross multiply. So 8x equals 5 times 12. Isn't that 60? Correct? And then divide by 8. Does that come out nice? Yes or no? Not really. So I had a rule last time. I said, should we have a decimal or should we not have a decimal? The kind of problems we had where we did not give decimals was algebra problems. Correct? Is this an algebra problem? I think that's a geometry problem. Correct? Isn't this like trying to find a distance, find this length, all that stuff? So punch it in. What's 60 divided by 8, baby? 7.5, right? I think that 7.5 makes perfect sense for that. So let's say, hey, how long is that? What's the distance from B to A? I'd say 7.5 units, right? Instead of 15 halves units. You with me on that? This is not an algebra problem. This is a geometry problem. Cool? Let's find y. What I want you and Pal to do is set up a proportion to find your y. Here's y right there, right? See if you can set up a proportion to solve for y. Scale factor equals proportion. Here's y right there. Let's find y. My scale factor is what, my friend? 8/5, 8 over 5. And what does y correspond with in this problem? 18, right? Y'all cool with that? So should it be y over 18 or 18 over y? It has to be y over 18 because we're doing big over little, and we know y is bigger than that because it's in the big polygon. Is that cool with us? So cross multiply. 5y equals 80 and 64, 144, is that right? And then y equals, that'll get a decimal. Does it come out nice? What'd you get? That's a nice decimal. 28.8, or is it 28.75? 28.8. That's a nice decimal. What's not a nice decimal is something that fills up your whole calculator screen. Now what if you got a repeating decimal? Like 0.3 repeating. Do you know what that is as a fraction? So like if I tell you this, 8 divided by 3. Don't put 2.6 because that's not what that is. I want to know, what is that as a compound fraction? What's 0.6 repeating as a fraction? Isn't that, I'm sorry? Don't round it to the nearest. I'm not telling you to round. I want to know what that is exactly. Repeating decimals come out nice every single time. 0.3 repeating, you ever seen that? Well, now we got two different questions going on here, right? Have you ever seen 0.3 repeating before is what I'm asking you. Do you know what fraction that is? It's 1/3. What's 0.6 repeating then? 2/3. So let's learn a little cool secret. Okay? 0.1 repeating is 1/9. Awesome. 0.2 repeating is 2/9. 0.3 repeating. What is that? It's 3/9, which is really what? 1/3. So what's 0.4 repeating going to be? 4/9. What's 0.5 repeating? 5/9. What's 0.6 repeating? 6/9, which is really what? 2/3. What's 0.7 repeating? 7/9. 0.8 repeating? 8/9. Mind blowing time. Are you ready to get your mind blown? What's 0.9 repeating? It's 9/9, which is what? And that's chaos right there. There's a whole field of mathematics called chaos theory, and this is the introduction to it. That's 0.9 repeating is really the number 1, and that doesn't make any sense. Chaos right there. 0.9 repeating is the number 1. But anyway, if you have any repeating decimal, it's always over 9. So this, back to my question, 2.6 repeating is 2 and 2/3. Are you with me on that? 2 and 2/3. Because I don't have enough time to explain that to you. Does that make sense? Trust me. It's just trust me. If you'd like the proof, I'll do a few pages of it for you. Okay? Next problem. Are these two polygons similar? Yes or no? Someone said yes. Tell me how you knew that. It tells you so right here. There's a similarity statement. Okay? Next move. They're asking you to find X, Y, and Z. There's a typo right here. Let's cross this guy out. This W shouldn't be there. Let's call that Z. Okay, and that's a typo. They're asking us to find X, Y, and Z. We can do that knowing that these are similar. Cool? First thing we need. What do you think? Before scale factor. Before we even scale factor, you're right. The first thing we need is a scale factor. What's the first thing we should do? Big and little. Big and little it. Big and little it. B and L. That saves lives. Keeps the proportion all nice and balanced. Now find me a scale factor. Find two sides that correspond to each other and you know both their lengths. We got the 30 and the 20, so that'd be 20 over 30 or 30 over 20? We're going to do big over little every time. Could you do it the other way around? Of course you could. I just want us all to do it the same way. Does that make sense? So can 30 over 20 reduce to what? 3 over 2. Now let's find the values of x, y, and z. Let's start with x. I'll help you get started. Here's x. What does it correspond with? 21. So we'll set up our proportion. Start with the scale factor first. What's the scale factor? 3 over 2. That will be equal to, should it be x over 21 or 21 over x? Big over little, baby. Daddy likes it. 3x. What did we get for x? I guess you're still working, that's fine. Did you get 14? Then I would put it two places. I would put it here, whop, whop, in the answer blank, and then I would also go back and put it in a picture. It's just nice. If you have information and you have a picture, you should put that information in the picture. Find y and z for me, por favor. If you pause the video and to get that done. Once you have found it correctly, answer the next question. Just find their perimeters. What do we get for a perimeter of ABCD? 52. Is everyone cool with that? How do you say these? I don't remember if I've told you this. How do you say those things out loud? Not told you? Prime. A prime, B prime, C prime, D prime is what that's called. How do you find that? Or what is the perimeter of A prime, B prime, C prime, D prime? 78. Just adding up side lengths, right? Much easier to do when you put the information back in the picture, too, right? So find the ratio of their perimeters. Should we put it as 52 over 78 or 78 over 52? Big over little, right? 78 over 52. Do you think that that reduces? Yes or no? Yeah? They're both even, so we could reduce it by 2. I'll tell you what, I'll save you a lot of time. 26 goes into each one of those, right? Reduce that by a factor of 26. I'll bet you'll be super shocked of what that reduces to when you reduce it by a factor of 26. What does it reduce to? 3 over 2. What's so fabulous about 3 over 2? That was our scale factor. Now, let's see if you can hook it up for later. The ratio of the perimeters of similar polygons will be the same as the scale factor every single time. You don't need to find the perimeters to answer that question. I'd like to repeat that. You don't need to find the perimeters to find the ratio of their perimeters. If they're similar, which they are, the ratio of the perimeters will be the same as the scale factor. Now let's take it a step and beyond. What if I asked you to find the ratio of their areas? I don't even know how to find the area of that shape, right? It's a quadrilateral, correct? It does have an area. There's some space inside, but what would be the ratio of the areas of those? I don't need to know their areas to figure it out. Are they similar? Yes or no? Do I know the scale factor? Now, all you need to know is the label that should be an area. Is it units, units squared, or units cubed? It's square units, right? Is an area in square units, correct? So all you have to do is take the old scale factor of 3/2 and square it. Cool? Now, those of you that are too calculator dependent, you need to understand how to square a fraction. Does anybody in here know what 3 squared is? Does anybody know what 2 squared is? So you just square each number. What's 3/2 squared turn out to be? So if I asked you what's the ratio of those guys' areas, since the scale factor is 3/2 and area is in square units, that would be 9/4 the ratio of their areas. Now let's pretend they were three-dimensional shapes, which they're not, but let's pretend. What would be the ratio of their volumes? What kind of label do you put on volume? Cubic. So you take the scale factor and you cube it, and 3 cubed is 27, and 2 cubed, what's 2 cubed? What's 2 times 2 times 2? What's 2 cubed? 8. The ratio of their volumes is 27 over 8. They're going to ask you some tricky questions, and maybe you've even seen some of those on the STAR test before. It's like, these are similar to each other. What's the ratio of these guys? It's perimeters. What label goes on perimeters? First power, second power, third power? First power. That's why we got 3/2. Areas. What label is area? Squared. And volume is third power, correct? So all you got to do is do that to the scale factor. Backside. Number 1. Are they similar? Well, I don't know. This is a bad worksheet. They don't tell us. So let's assume they are. Since they say find the scale factor, what's the first thing you would do to find the scale factor? Okay, find two correspond to each other, and you're like pretty close. One thing before that. What's the one basic thing you should do first? Big and little. Big and little. It should be your first move. Then, what do you think? What if I use this 10 and this 24? What do you think about that? Why wouldn't that work to find the scale factor? Okay, they don't, starts with a C. They don't what? Correspond to each other. What would you have to use if you chose this 10? The 15, so it would be 15 over 10, right? Big over little. What's 15 over 10 reduced to? What number goes into both of those, baby? 5 does, so it'd be 3 over 2. Is the scale factor always 3/2? No, the scale factor is not always 3/2. In this case, it was. If I did 24 over 16, don't those correspond to each other? Should I get 3/2 again? I better. And same thing with 12 over 8. Shouldn't I get 3/2 again? Right? All the corresponding sides have the same scale factor. That's what it means when they say they're proportional. Do that on 2. Baby, baby, baby. Big and little m. And then these guys go together, the 16 and the 12. So big over little. In. 4 goes in each one of those, right? So what's that reduced to? 4/3 is the scale factor. Sound good? Next one. I don't want to do all these problems, okay? If we can do 3 and 4, if you can prove to me that you understand what's going on, we'll stop. What's the first thing? First of all, are they similar? Yes or no? Because they tell us so in the instruction. First thing you should do, big and little. Get me a scale factor on number 3 real quick. Get me a scale factor on 3. Sometimes it helps to even like kind of label what you're doing. You know, it's like scale factor is 12/8, which is really 3/2, right? Now find x. If we can find x and y successfully in this first problem, we'll stop. Find x for me. Yeah, 10 for this. X corresponds with 22, right? Should it be 22 over x or x over 22? That's the question. Big over little, baby. Big over little. And then y's next. Why? Because I said so. Why? Because I said so. Question for you. I don't want to find the perimeters, even though I could. Don't I have all the lengths represented? What's the ratio of the perimeters of these two bad boys? 3:2, right? What's the ratio of their areas? You don't even know how to find the area of these triangles yet because we don't have a height and all that stuff, but we could do it. What's the ratio of their areas going to be? Not 3:2. That's the ratio of their perimeters. It's not 3:2. It's 9:4. How did you get 9:4? You take the scale factor and square it, right? And if there was a three-dimensional shape and I asked the ratio of their volumes, what would you do to the scale factor? You'd cube it, baby. All right. Need to help you with your homework here real quick. At the top of your homework, here's the first thing I want you to do. There's 2 rules to be similar. Please write those 2 rules at the top of your homework for me. What are the 2 rules to be similar? See if you can do it without looking them up. 2 rules to be similar. 1 and 2. What's rule number 1? Corresponding angles have to be congruent. The magic word is corresponding, right? Not all the angles will be congruent to each other. It's not like they're always going to be 90, 90, 90, 90, 90 or something like that. The angles that correspond to each other are going to be the same. What's rule number 2? Corresponding sides are proportional. P-R-O-P. So let's do number 1 together. I've done this worksheet years and years and years, and every time I don't explain things to people, they're like, I don't get it. Are the quadrilaterals similar? If not, tell why. Number 1, ABCD and EFGH. The first couple years I gave this, people would be like, I don't know, because they didn't look down here. Do you see those quadrilaterals down there? So let's try it now. ABCD and EFGH, are they similar? Here's ABCD, and here's EFGH. There's 2 rules, right? Let's check both rules. Are corresponding angles congruent to each other? Isn't that rule number 1? Is that happening? Well, I don't even know what corresponds with what, but I can guarantee you that the corresponding angles are congruent because these are all 90 and those are all 90. Correct? Corresponding sides, are they proportional? And you went here to, what's that scale factor? 5/2. If they're truly proportional, then you have to get 5/2 every single time you go around. If you went over here, this one and this one, would you get a scale factor of 5/2? So Are these similar or no? No. And now they say, if you'd say no, tell me why. Why aren't... There's two rules which will get violated. Corresponding sides. And then what was going on in here? They were what? Not proportional. You can abbreviate. By you can abbreviate. Corresponding sides are not proportional. You understand what to do on those problems. What if you say yes? What do you have to do? Read the instructions. What if you say yes? You just say yes, right? You don't have to do anything else. Sound all right? Next set. If you answer no to any of these following questions, give a reason. Isn't that what your instructions say now? Give a reason. So let's do number 5 together. If the corresponding of two polygons are congruent, must the polygons be similar? Yes or no? Well, there's two rules. I want you to go through each one of these problems by checking through those two rules. Rule number 1, corresponding angles are congruent. Is that satisfied in problem 5? Yes. Rule number 2, corresponding sides should be proportional. Is that satisfied in number 5? I have no idea, right? So must they be similar, yes or no? No? What's your reason? Corresponding sides must be proportional to. Like 2 is in also. T-O. You with me on that? And here's a counterexample that we just had. Weren't these corresponding angles all congruent, but the corresponding sides were not proportional? I mean, there's a plain old counterexample right there. You know what to do on the rest of these problems. Very much like that. Okay? So try number 6 real quick. Yes or no? Answer was no, and I hope your reason makes sense. Awesome. To the next page. Gets a little confusing on 10. See this? Are those similar to each other? Yes or no? See this? Are those two similar to each other? Yes or no? Yes. Yes. That's what I'd do next. Cool? Then they say measure of angle y equals. What I need you to put in this blank is a number, right? Put a number in this blank. Don't put measure of angle y prime equals measure of angle y. Don't put this. That's not what I want. I want to know how much is the measure of angle y prime equal. So let's do that real quick. Here's y prime, correct? How much should that be? How did you get 70 degrees? Isn't it correspond with angle y right here, according to the statement? You with me? And corresponding angles are congruent, so 70 degrees. Excellent. Next set of problems. Oh, wait a minute. That's what I wanted to do. And then when they're asking you to find like distance from D to U, distance from y prime to j prime, and etc., I would do this. I would like make up variables for them. So like when you want to find the distance from D to U, I'm going to put like an x there. You with me? And then I'll find my scale factor, and I'll set up a proportion with this x. Cool? When I ask you to find the distance from y prime to j prime, which is right here, y prime to j prime, what variable can you not use? You can't use x. You already put x right here. So what do you want to use instead? I'll put a y there. And then when they ask you to find the distance from j prime to u prime, you can't use x and you can't use y. You better use a different variable. Does that make sense? Like instead of using those distances, we just make up a variable and call them that, and those variables. Okay. Next. Tell whether these polygons are always, sometimes, or never similar. Let's do number 11 together. 2 equilateral triangles. When in doubt, sketch it out. Sound cool? Check me out. Sketch with me. There's the 2 triangles. Sketch with me. What's an equilateral triangle again? What's an equilateral triangle? All sides the same? And then wouldn't all the angles be the same also? Do you know what each angle measures inside of there? If it's equilateral, 60, 60, 60, 60, 60, 60, right? Make up a side length. How about 2, 2, and 2? Is that an equilateral triangle right there? 2, 2, and 2? So how about this one? 4, 4, and 4. Is that an equilateral triangle right there? They want to know if they're always similar, sometimes similar, or never similar to each other. Let's go to the two rules. Number one, will corresponding angles be congruent? Yes or no? They have to be. It's 60 degrees in each triangle. Will corresponding sides be proportional to each other? Scale factor, 4 to 2, 4 to 2, 4 to 2, right? So both rules are satisfied. Will they always be similar, sometimes be similar, or never be similar to each other? Capital A for always. If you want to write out always, write it, but A, S, or N is all I really care about. Let's go down to number 13. Two isosceles triangles. Well, let's think about it. Will the corresponding angles be congruent to each other in an isosceles triangle? Every time. What's an isosceles triangle again? It's got how many sides the same? At least two, right? And the base angles are the same, right? So if I draw an isosceles triangle right here, just for fun, let's even put some numbers in there just for the heck of it. Let's go 30 degrees, 30 degrees, 120 degrees, right? 7, 7. Isn't that an isosceles triangle? Now I'm going to draw another isosceles triangle. Do I have to draw it with the same set of angles in that situation? I do? 45 degrees, 45 degrees, 90 degrees, 6, 6. Is that an isosceles triangle? Right? Are they similar to each other? What do you think? Are they similar to each other? Why say yes, Megan? Okay. These are not similar. Is it possible to draw an isosceles triangle that is similar to this one, though? So always, sometimes, or never. Will two isosceles triangles always, sometimes, or never be similar to each other? Sometimes. They can be, but they don't have to be. Do you understand what I'm trying to look for in there? I don't need you to sketch a picture for me. When you're stuck, you should probably start sketching some pictures to start asking yourself those questions. Cool? One other thing I want to talk about. Just to show you how to do something. What if you wanted to take 3 times, just say, 5 radical 2? Right? Taking numbers times stuff with radicals. Guys, you treat you treat a radical like it's a variable. Do you know what 3 times 5x is? What's 3 times 5x? It's 15x, correct? So what's 3 times 5 radical 2? 15 radical 2. The other thing is, I've noticed it just takes y'all some getting used to say that out loud, correct? What is this thing called? You can call it radical, or you can call it square root. Either one of them. 15 radical 2, or 15 square roots of 2. You with me on that? You take numbers times numbers, and radicals times radicals. So what if I wanted to do 7 radical 2 times 3 radical 5? What's 7 times 3? Yes, you can. You can multiply anything you want to together. What's 7 times 3? 21. What's radical 2 times radical 5? It's radical 10. You cannot add them together because they're not like terms, but you can multiply them together. Just like if I asked you to take 7x times 3y. Aren't those different radicals? These are different variables. You get 21xy when you multiply them together. Right? You can multiply anything you want to together. You just can't add things together unless they're like terms.